Hey, welcome to the Q&A session on resourcing beyond Earth, part of the Earth Materials Frontiers webinar series. Glad some folks could join us. We're going to wait just one more minute to see if there are any other folks that are going to jump in, and then we'll start our Q&A. We will begin momentarily. Okay, why don't we go ahead and get started? Be respectful of everyone's time. I'm pleased to introduce Angel Abu Madrid. Hopefully, everyone had a chance to watch the wonderful presentation that he has done for Earth Science Week for this webinar series about resources beyond Earth. This is a Q&A session. Hopefully, we can just run this as a conversation. I know we have a number of folks here, and if you would like to verbally ask a question or have a conversation, please feel free to unmute yourself. If you would rather use the little chat button and type it in, I'll be happy to ask the questions for you. So I don't know if anyone has an immediate question. Perhaps to just warm up, I do have one for you that had come in earlier. So you discuss a lot about mining of water and similar volatiles, within your talk. Are there different energy-intensive processes that you're expecting to see develop for the extraction of metals, since that can be obviously a different kind of environment?
Mm-hmm. Yeah. Well, first of all, thanks, Chris, for putting together this session. It's a pleasure to be with all of you here on this Earth Science Week. I think it's a great idea. This is my first participation here on a topic that may be a little bit unusual, but I think it's of importance to materials and minerals beyond Earth. So yes, you mentioned other processes to extract not just water, but metals. So the thinking is now, and I mentioned this, water will be probably the first objective, just because it gives us a lot of things that are very useful. They could be propellants, human consumables, radiation shielding. But as important as water, and water is concentrated on the poles. It's a very difficult region to get at. So why not, for example, get the oxygen that is everywhere around the moon? So to get oxygen, that's great, because as a propellant is probably 83% of your mass that you take. So that would be great to get your oxygen, and then you carry your own fuel. But in the process of getting oxygen, you actually can get metals. Some of the processes that are being proposed, and some of them have actually been tested, it's a process, for example, hydrogen reduction. We all learn at some point in college or high school, there's oxidation and there's reduction. So if you have lunar regolith, and you have a mineral that is very abundant, ilmenite. Ilmenite is a combination of iron, titanium, and oxygen. So if now you flow hydrogen through that, you will get water, and then from the water you can dissociate it and get your oxygen. But as a residue, you get all the metals. You get the iron, you get the titanium. And so these are some of the processes that are being explored to obtain it. That is probably the lowest in terms of energy. You have to just elevate the temperature to about 600 to 700 degrees Celsius, and then you can get the metals. There are some other processes that work in any mineral. I mean, it doesn't matter if it's ilmenite. You just fuse the whole material, and then you segregate the metals. But that, you need a lot of energy, and that has to come from solar energy. And so these are some of the processes that are being explored to obtain the metals from the surface.
Excellent. Any of our guests, if you'd like to unmute and ask questions, please do so. Okay, so while people are thinking up their questions, what what do you see as some of these applications? Your examples are very much driven on space exploration and the development of a transport system within this area. What do you see some of these applications that would be of economic value to humankind, with these approaches that are being applied? Or what's that next step that you see?
Mhm. Yeah, so the first uses of resources in space, it's obviously using them where they are right now. And why? Right now, transportation to space is the most expensive part of the whole process. And that's why only a few countries have gone up there. Less than 600 people have access to space. So the moment you lower transportation, just like on Earth, it will open up all sorts of activities. Companies like SpaceX have been working on that by using those reusable rockets that you probably have seen. But that has reduced the cost only to low Earth orbit. If you want to go beyond that, then you're going to have to refuel in space. And so the first thing is lower your transportation cost. That's why water is important. The moment you do that, then you start thinking about, well, what else can I do now? Well, right now, all of the satellites that we send into space, they have a limited amount of fuel. Once they run out of that, they become space debris. So what if you can refuel now your satellites and extend their life? So now you start bringing more value to those companies that are launching satellites. Then any operation on the moon actually will be much more economical because now you can use the resources from there. So now you start thinking about base on the moon, and that actually can bring opportunities for companies to do things like beaming solar energy from the moon, or staying there for longer periods of times to start extracting elements that could be useful in the future, like helium-3, an isotope that I mentioned there that could be also useful. But most importantly is that you open up the what's called the cislunar economy, the distance from here to the moon. So you open now the possibility of having rockets that can be up there for a limited time, satellites that can be refueled. You lower the whole cost of for communications, and that has a direct impact to us here on Earth at the beginning, and that will open up other ventures in the future as you start lowering that cost.
So you mentioned, excuse me, groups like SpaceX and the like. So where do you see, as sort of this fuel and transport system develops, where do you see the divide between the private corporations and the space agencies for the various countries? It's a much more mixed bag than back during the heyday of the space race.
Mm-hmm.
How do you see that dynamic playing out?
Yeah. At first, there's has to be at some point some private public partnership on this, just like in anything, just like highways and aviation and railroads and everything else. The government will have to step in at the beginning to allow, for example, just the prospecting aspect, just to identify the resources. The government can do a lot to identify those, and then bring the private sector start playing an important role. NASA has already done that by allowing private companies to transport materials to the space station. Now that we're transporting even humans, SpaceX actually just did one. He was going to do one in next week, but now has moved it to November. So now it's now given the private sector an opportunity to get more involved, and with that lower the cost and be able to do more things. So at first, they're going to have to step in, but at some point, then you're going to have to let the private sector and the market get in that. What we see is that NASA will benefit greatly by having much less expensive propellant. Some of the economic analysis that we have done is that if you can get propellant from the moon, the cost from launching anything from Earth to the moon will be reduced by 3 times. And if you want to just have a spacecraft for NASA going back and forth from a station going around the moon, that's about 70 times the reduction in cost, because you don't have to carry it from Earth. But at some point, companies can start benefiting just by what they do now. There's a company, United Launch Alliance, for example, that sends satellites to geosynchronous orbit. And they came out 4 years ago with a plan saying we actually will purchase propellant in space if you can meet a certain price. So they even put a price on the propellant. They said right now it costs us $4,000 to low Earth orbit. If you can sell it to us for $3,000, we'll take it. We don't care where it comes from, we'll take it. And so now what's happening is that companies are saying, well, how can I meet that price point? And if they do, then that will reduce the cost for that company to do whatever operations they're doing right now. For United Launch Alliance, will reduce the cost to get GPS satellites, weather forecasting satellites, communication satellites into space. And so that's when commerce starts really taking over. So at first, government helps us to identify the resources, get our infrastructure there, and then you let commerce take after that.
Very good. So we have a question here from Evan Powers. Greetings from the University of Cincinnati. My question is regarding the sentiment that asteroid mining for rare earth metals is prohibitively expensive as far as profits are concerned. What are your thoughts about the environmental social benefits of obtaining rare earth metals at a potential financial loss for the sake of avoiding strip surface mining on Earth, which will be necessary to supply a large-scale transition to battery-dependent renewable energy systems? I.e. a multi-government project versus profit-seeking industry?
Mm-hmm. That's a really good question, because yes, if you look just from the economic point of view, it really doesn't make sense to go after them right now. But if you look at Jeff Bezos' view of the world, in which he says at some point it will be ideal if we can just import everything from space, go all the materials, and make planet Earth just a residential zone. I mean, that would be the ideal part, because then you don't have to worry about any environmental concerns or pollution or anything like that. But eventually, economics is going to drive this. And that's why I think that the crossing point, when it becomes feasible to go after resources in space to bring them to Earth, is when the cost is when the cost of taking it from Earth starts becoming so high, because at some point we're going to have to start drilling deeper and deeper, and now you're causing major environmental degradation, and companies are going to be charged for that. So and at that point you're also developing your infrastructure in space. At some point those numbers may be close enough that then it will make sense to bring in from space. And yes, the environmental part will be a major player. I mean, right now for mining companies, that's quite a cost. I mean, just to take care of the cleaning and make sure that everything's done right. So that brings the cost a little bit higher for operations. So at some point, that's going to be the main driver for bringing things from space. But it will take some time, I think, because we keep getting newer and newer technologies on Earth, and we're doing things in a much more efficient way and less impactful for the environment. But at some point, you're going to reach that cross point where it becomes more attractive to bring it from space.
Very good. Again, I invite anyone who has attended to, if you wish to verbally ask a question, feel free to unmute yourself. So,
hi, I guess I'll ask a question. My name is Catherine, and I'm in Canada. So I really like that comment about Earth being a residential space, because I work in land use geology and work on commenting on conflicting uses of land resources in order to maintain resources available for use. So I like that comment. But coming from, I guess, the legal or environmental perspective, what I was wondering was, considering, need an ethical extraction of resources on Earth could be debated, how would we avoid irreparable damage to the moon for fuel extraction there? I appreciate that would, make like a really good kind of gas station so that and prolonged use of space excursions. But I was wondering, that whole greed and, like you said, the use of the resources and the land, is a bit of an issue still on Earth that could that be, even exploded to a greater extent by use in space?
Absolutely, Catherine. And your concern has been shared by many, many groups about this new, as we start heading towards space, are we also exporting the same thing that we have done for centuries? And in the past, we have wiped entire civilizations in the process of obtaining resources, and that has not been a right thing to do. As we go towards the moon and asteroids and Mars and all that, yes, there's no living beings, although we may find life on Mars, we don't know, and that's a whole different conversation on a field that's called planetary protection. But let's take the moon. We're not going to hurt anybody, but we are dealing with non-renewable resources. You're absolutely right. We only have a certain amount of water there. So who is going to get a hold of that, and how are you going to regulate this? And so that's a very important question that is being asked now by different forums at the international level. I mentioned a group that was organized at The Hague in Netherlands, in which they brought representatives from developing and non-developing countries to start talking about this, because this is a unique moment that we have right now. We're starting from scratch. Yes, we have done a lot of bad things in the past, but hopefully we're mature enough to start something new. And so it will be a matter of everybody getting together and figuring out how we're going to do that so that it's a fair process. Yes, the market controls it, and you're right, at some point greed takes over, and that could be a problem. But if we can establish some rules, okay, who has access to this, how much are we going to use, who's going to benefit from this, then we can start afresh. And the concern, for example, that developing countries have expressed on this is that they're going to miss out on this, just like they missed during the terrestrial resources. And even the concern is even bigger, because they say, well, at least, for example, we had a meeting in Africa, and there were like 12 African countries that said, at least we own our resources and we let companies come in and at least we benefit. But over there, we don't own them, we cannot participate. What's in it for us? And so right now the conversation is how these new players can actually play a role in extracting the resources, benefiting from this, so that everybody can have a fair access to this. But that's a very, very important question. So again, we don't want to replicate what we did here on Earth. Might as well start afresh. And this has been talked in the United Nations. It's been talked by individual countries signing agreements. And hopefully we got the legal issues solved before we actually start heading there. But I think both of them are going to walk hand in hand. But absolutely, that conversation has to be had.
Great. Thank you very much. I appreciate that.
No problem.
Any of our other guests have a question?
I did have a question. I saw at the end of your talk, you had many companies and organizations that are currently seem to be working in this area. So I just wanted to get a sense of how big is the community that is working on the space resources at this point?
Mm-hmm. Another great question, because as I mentioned, one of the three important elements to extract resources, you got to identify your resource, the technology, but you got to have a customer. And so about 10 years ago, if you had asked me who's interested, it was pretty much just space agencies. We did approach about 10, 15 years ago some of the mining companies and even oil and gas, and they just thought this was science fiction back then. But now that so many countries are interested and there's money being put to make this happen, more and more companies are coming into the fold. And what's happening is that it's not the large companies, it's actually a lot of startups and medium-sized companies that are getting interested, and not to do the whole thing. You know, the first couple of companies that showed up around 7 or 8 years ago, they wanted to do everything: launch, do the prospecting, do the excavation, the extraction, and bringing it down to earth. That was too ambitious, and even though they were backed up by billionaires, they didn't make it because it was not a good business case. So what you're seeing now is all these small companies that are saying, I'll do the remote sensing, and I'll develop a drilling system, and I'll develop the excavators, and I'll do the separation, the purification, and somebody will come with all the infrastructure that is needed. You need a GPS system around the moon. Somebody's developing that. Somebody needs the power. So there's some companies that are coming out with modular nuclear reactors to operate in extreme conditions. So now you start having a whole ecosystem developing on this. And now the large companies, and we have approached some of the large mining companies in oil and gas, now they're interested. Every time we talk to them, they want to see numbers. So we give them, how much is this going to cost? And we have done some analysis, and let me just give you one example. A company like United Launch Alliance said, purchase propellant in space, if you can give it to us at $3,000 a kilogram in low Earth orbit to refuel 3 rockets for our normal business for 10 years. How much is that going to cost? And so we had a team of 25 different groups from academia, from industry, from space agencies, look at everything that will take to put an ice mining plant on the poles of the moon. Everything from launching the equipment to installing it, to maintain it for 10 years, to do everything that is required. And the numbers come about between $3 to $4 billion for the operation, with a rate of return of about 19% in 10 years. There's going to be a large cost at the beginning, but eventually, after 10 years, you start getting about 19%. And if the government gets involved, it goes up to 24% or so. So large mining companies said, look, that's not scary at all. I mean, we do that all the time on the Gulf of Mexico for oil, on mining companies, on mining operations everywhere around the world. That's not a scary number for us. We do that. Maybe the rate of return, we'd like it to be a little bit higher because it's a riskier operation, but we're interested. The only thing we need to know is that tell me that the resource is there. They want to have proven reserves, and tell me who's going to be my customer, who's going to buy this. And third, tell me that this is legal. I don't want to touch it if you tell me that this is prohibited by some international treaty. So companies are now thinking this is a possibility. And some of the large mining companies are saying, because they're very conservative, they're saying, well, we'll let the juniors go in first. Once they become successful, then we take over. And that's a general attitude that happens also on Earth. But now they're thinking this is an interesting operation for us, especially as they start moving towards other areas of interest. Like there's companies in the oil and gas business that are moving to the hydrogen economy. So now we're talking hydrogen from the moon. So that's pretty much in line with their business. So you start seeing those type of companies interested. You also see the equipment manufacturers. You see Caterpillar, and you see Schlumberger also getting interested from the point of view of doing all the analysis before that. Because for companies like Caterpillar or others, the interest is that once you develop this automated systems that work in very rough environments, wouldn't it be great to just have the same type of technology on very hard to reach mining operations here on Earth, radioactive mines, very deep. And so the interest is both terrestrial and space. And that's how they see the interest at the beginning for them. And that's happening a lot of also with these small companies. They have this dual purpose in their business case. Let's develop something that may work here on Earth. We have capital to work on this as we develop the technologies to do that in space. So you're seeing companies now developing drilling systems and excavators that can work in both places. And that's how you get companies interested. And that's why the number of companies just keeps going up every day, because now they see there's a new frontier. Here's a new way to do things.
So building from that question, when one of the things I do, I talk to a lot of geoscience students and college students in general. For the current generation of students, and they're interested, they're enamored by this entire emerging industry. What are the sort of the key skills that you see that are going to be in demand, that and pathways that these students should be thinking about if they want to engage in this long term?
Yeah, great question and timely. At the Colorado School of Mines, we have been working on the aerospace resources for 20 years on the research side of things, when this thing was not even popular. But seeing the interest that is now international, that is coming from the private sector and space agencies, we also decided 2 years ago to launch the very first program in the world that educates students and professionals on this field. And we offer, at this point, graduate degrees on masters, PhDs, and certificates. And the way we structure our program is that we realize this is a very multidisciplinary program, multidisciplinary field. You're going to need scientists and engineers and economists and policy analysts and entrepreneurs. And so what we offer is courses that will expose you to all the important things of this field. And then depending on your area of expertise, we offer technical electives for people that want to go into the prospecting aspects, the extraction, power, who wants to go into the legal aspects and the policy. And so I tell prospective students that they ask me all the time, what do I need to get involved in this? Just be good at what you do right now. If you're a good miner, fine. If you're a good roboticist, that's what you need. And then you will get educated in all of these different aspects. And that's when you start making the contribution. Because a lot of times engineers are enamored with their technology. Oh, I have this great technology to extract metals from this part of the moon. Well, that's great, but is anybody going to pay for that? So you got to learn about the economics of this and about the legal issues. Same thing with lawyers and economists. They need to learn about transportation. How much energy does it take to get a rocket from point A to point B? So they need to get this multidisciplinary approach to get started on this field, but then be good at what you are. Because if you're good at designing systems or excavation systems on Earth, then it's going to be, we actually need that expertise to do that in space because you know that better than anybody else. NASA has told us, we're great at building rockets, we don't know anything about mining. So that's why they're going to get involved more and more commercial companies that know how to do the things that space agencies don't know how to do this. So be good at what you are, educate yourself about this topic, and then start thinking, like I said, outside the planet. I design things here on Earth. Now I'm going to change the vacuum, the temperature, the pressure, the radiation, the automation. How do I do that? And that makes it very challenging, but also very exciting for students right now, because now they can start developing things that are totally new, and they're going to function in a completely different environment. So that brings a level of excitement to the thing that they're doing terrestrially right now.
Excellent. So any of our guests have another question? There's one that came in on the chat. So how long do we expect these resources to provide for us, and what happens when inevitably they're all used up?
Good. It depends what resource we're talking about. In general, resources beyond Earth are pretty much limitless. I mean, it's just, there's water everywhere, for example. All the asteroids, the millions of asteroids in the asteroid belt and near-Earth asteroids contain large amounts of water. Yes, the moon is going to be the first object we're going to go after because it's close, because we can operate. It's just 3 days away, and we can operate from here. But at some point, a lot can come from asteroids. And asteroids, in fact, in terms of energy that it takes to get there, you need less energy to get to an asteroid, which may be months away, than to get to the moon, because they don't have any gravity. So you don't need to decelerate and land and all of that. So actually, it's easier to get to them energetically. And they got there's plenty of resources there. A lot of them contain about 20% of water. In terms of metals, again, there's plenty. If you have one asteroid of the type M, the metallic type, that have all the noble metals like platinum group metals and the like, the size of, I would say, 3 kilometers or so in diameter, it has more platinum than has ever been mined and that will ever be mined on Earth. Just one single asteroid. So there's plenty of material there. Is that, how can you make that economically? And at some point, if you think in the future, that's a major source of materials for Earth. Once we have the infrastructure there, you don't have to worry about that. Things like water on the moon, that is definitely non-renewable. Right now, the amount of water on the poles, and I made a comparison there with, I think was one of the lakes, small lakes on the Great Lakes regions, St. Clair, I think it was. It may not look that there's much water there, but in terms of humans living on the moon, you may not need that much water because like in the space station, you can recycle up to 90% of the water, and you clean up your waste and you're actually drinking whatever you produce. So it's mostly for propellant. And that amount, the calculations show that it's good for thousands and thousands of rockets. So it can last us for a long time, hundreds of years. So it's very similar to oil. In fact, that's why we call sometimes water the oil of space, because it will provide us fuel for transportation. Is non-renewable. It can last for 100 years while you start looking at how you get it from other places like asteroids. So there's plenty of resources out there. It's just develop the right infrastructure that will make it economical to use them. Plus, there's also the intangible resources like solar energy. If we can at some point harvest solar energy from orbit and beam it down to Earth, I think that will be probably the major contribution from space resources, because all of a sudden you got plentiful energy. You don't have to worry about all fossil fuels and all sorts of things. So those things are important, tangible and intangible resources. I see Catherine turning on her mic, but maybe not.
So I've got one for you. I'm sure you've been asked this many times before. So what are your thoughts about how the book The Martian and say For All Mankind, the new series on Apple, that they're actually touching on some of these topics? How do you think that they've treated the science and the realities of it relative to storytelling? Are they reasonable approximations, or are they way off?
Yeah, you're right. More and more you start seeing that in novels, in movies, because even Hollywood has realized that that's going to be the way to go. I mean, right now in space we have carry everything with us, but if we really want to have a base on the moon or Mars, you're just going to have to use their resources. So they're getting creative of what we expect to see there. The Martian was a case that brought a lot of attention to that, because they show there how is that you're going to grow plants, how are you going to extract oxygen from rocks and water and all that. There were some cases in which they took some scientific liberties, absolutely. I mean, they show, I think at the beginning, this big storm on Mars. Yes, there's sandstorms on Mars, but it's such a thin atmosphere that you're never going to see those type of extreme conditions. Obviously, they have to make it easy to see how they can, get their plants to grow and all of that. I think it was well done. I think the techniques that they showed to do it, they're fine. It's just that they made it seem, much easier for somebody to figure out, okay, I'll have to do this and I'll do it quickly. Well, it may take some more thinking to do that. But I think that those movies help to start making the public thinking that this is doable. That if we ever want to go to Mars, it's impossible to do it the way we've been doing it right now. You cannot carry with you the fuel to escape Earth, to get to Mars, to descend, to use it for all the things that an astronaut has to use there for a year and a half, then all the fuel to come back, slow down, and get to Earth. That's just too expensive and extreme. So you have to start thinking, well, what is that I can use? And we do that all the time. I mean, every time we go somewhere else, well, maybe I can make goods wherever I go. So start thinking, okay, how do I get the water? How do I extract the oxygen? And if I have carbon dioxide, well, maybe I can have carbon, and with that I have methane, and maybe I can make plastics. And how about if I use just the soil to make bricks and mortar? And so it's great that the public is thinking about this. And again, you're seeing more and more novels, and people get very creative, and they start actually sending us suggestions, why not do this in order to get this type of metal? And so that what these movies have done is to really get the imagination of people excited about how is that we're going to be able to survive in a different planet.
Excellent. So I will open up the floor. One last question. I don't want to keep everyone. Any last questions? Okay, Angel. I really appreciate your time. This was a go. We have some thanks coming in, and I agree. This has been spectacular. Great conversation, and a terrific presentation that I think is a lot of food for thought for, not just folks interested in space, but people across the sciences about, where we all are moving. So again, I appreciate your contribution to this effort and look forward to seeing the ongoing developments.
Absolutely. I think you made a good point there, is start thinking about what comes next. Yes, we have a lot to do on our planet to make things better, more efficient, cleaner, but we're more and more thinking what comes next, and we better get ready for that. Yes, these are the early years, but you're going to start seeing a lot of this. Actually, keep an eye on the news, and you start seeing more and more of what's happening in different countries doing this type of things and companies as we prepare for the next step. So hopefully it's a good one.
Thank you.
Okay.